Okay, so I have an arbitrary triangle over here, and I drew an altitude from B to AC, and I'll call it D. So these are right angles. I'll name this A. I'll name this C, and I'll name this whole thing B. I'll name this B1 and B2. Sine C, I call this H for height. So sine C is that's opposite over hypotenuse, so it's H over A, and I want to isolate the height. So A sine C equals H by multiplying A on both sides, and we can do cosine C, which is adjacent over hypotenuse, which is B2 over B2 over A. Sorry, and then we can isolate B2. And then we would use Pythagorean theorem on the triangle on the left. So A squared plus B squared equals C squared, except A is B1 and H is B. A is B1 and B is H. So instead of writing C squared equals A squared plus B squared, we can write C squared equals B1 squared plus H squared. But instead of writing the H, we have the H on top. We can just substitute the H we have on top. Put the H first. A sine C squared plus, and we don't know what B1 is, but we know what B2 and B is, so we can do B minus A cosine C from here, A cosine C squared, and then we can just use the exponents. Just get rid of the exponents. So A squared sine squared C sine C squared plus, and we need to factor this out. When we factor out, we get B squared minus 2AB cosine C plus, I believe it's A squared cosine squared C. And you can factor A squared on this and this. So we get C squared equals A squared sine squared C plus cosine squared C plus B squared minus 2AB cosine C. And we know that a trigonometric identity is sine squared theta plus cosine squared theta will always equal 1. So we can just write C squared equals A squared 1 plus B squared minus 2AB cosine C, and this is the same thing as C squared equals A squared plus B squared minus 2AB cosine of C, which is the law of cosines.